Before model making and working on architectural drawings, we need to understand the basics of scale and how scale can be applied into your drawings and models. Well, what is scale? Scale is used to produce presentation, drawings, and models of the architectural design. As most architectural, construction, and engineering, drawings are scaled to conveniently fit on a reasonable size of paper. Scale also helps us better understand the dimensions of the space we're designing. And in the architectural science program, students will use scale for all their drawings such as plans, elevations, sections, details, and of course, your models. How can we use and understand scale? To understand scale, we will first look at the differences between scales by using pieces of cut cardboard. Here I am cutting 4 strips of cardboard at various scales that all represent 1 meter in real life. At the scale of 1 to 100, every meter translates to 1 centimeter. At the scale of 1 to 50, every meter translates to 2 centimeters. At the scale of 1 to 25, every meter translates to 4 centimeters. And at the scale of 1 to 10, using the 1 to 100 scale, we know that every meter translates to 10 centimeters. So now we are going to show you how to read any scale you want on a typical metric ruler with a simple calculation starting with 1 to 100. So for 1 to 100, let's say you want to figure out how much a meter is. Divide it into 100 parts, which would give us 0.01 meters, which is equivalent to 1 centimeter. So for every meter on this ruler, it's every centimeter, so that's easy for us. For 1 to 50, you take 1 meter and divide it into 50, which gives us 0.02 meters, which is equivalent to 2 centimeters. So every 2 centimeters on this ruler, it's 1 meter at the scale of 1 to 50. Moving on, for 1 to 25, 1 meter divided by 25 gives us 0.04 meters, which is the same as 4 centimeters. So every 4 centimeters on this ruler is 1 meter. For 1 to 20, 1 meter divided by 20 gives us 0.05 meters, which is the same as 5 centimeters. So every 5 centimeters on this ruler is 1 meter at 1 to 20. Finally, for 1 to 10, 1 meter divided by 10 gives us 0.1 meters, which is 10 centimeters. So every 10 centimeters on this ruler is 1 meter at 1 to 10. For 1 to 5, 1 meter divided by 5 gives us 0.2 meters, which is 20 centimeters. So every 20 centimeters on this ruler is 1 meter at 1 to 5. For these examples, I was using 1 meter every time. You can substitute whichever value you want and divide by the scale you are working with, which would give you a dimension at that scale. And you can measure and draw to the correct scale every time. For an example, let's say you have a rectangle that is 8 meters by 6.5 meters and we want it at a scale of 1 to 50. We take the 8 meters divided by 50, which gives us 0.16 meters. So this dimension at the scale of 1 to 50 is 16 centimeters. Now we take the 6.5 meters divided by 50, which gives us 0.13 meters. So that is 13 centimeters. So this rectangle at the scale of 1 to 50 is 16 centimeters by 13 centimeters. So now we are going to go over an example where we convert from one scale up and then from that back down. So we have a wall that was cut at 1 to 100, which is originally 3 meters tall and 2 meters wide. At a scale of 1 to 100, it's 3 centimeters by 2 centimeters. For 1 to 100, going to 1 to 25, we take our 100 divided by 25, which is the scale we want to get to, which gives us 4. 4 is the factor which we will apply to the other dimensions of that wall. So starting with the 3 centimeters multiplied by 4 gives us 12 centimeters. Then the 2 centimeters multiplied by 4 gives us 8. So our new wall at 1 to 25 will be 12 centimeters tall by 8 centimeters wide. Now let's go over a reverse scenario where we're going from a scale of 1 to 25 down to 1 to 100, which is called scaling down. Using the same wall earlier, remember it was 12 centimeters tall by 8 centimeters wide at 1 to 25. For this factor, we will take 25 first, divided by 100 as that is the scale we want to get to, which gives us 0.25. 0.25 is the factor for this scenario. We take our 12 centimeters, multiply by 0.25, which gives us 3 centimeters. Then the 8 centimeters multiplied by 0.25 gives us 2 centimeters. So our wall at 1 to 100 is 3 centimeters tall by 2 centimeters wide. Now that we understand and can apply the use of scale and measurements to our work, it is also important to explain a bit about the imperial system, which we will do using this imperial ruler. So why do we need to know both the metric system and the imperial system? Well, the construction industry in North America is dominated by the US market, with whom we do most of our trading of dimensional lumber and sheet goods with. It is simply not cost effective to be producing to the metric standard and the imperial standard, so all the construction in Canada is done to the imperial standards. You will find that the products sold in the material shop are all dimensioned using the imperial system, including the thicknesses of dowels and sheets. The imperial ruler is marked with various lengths of lines. To begin understanding what each line means, first we need to go over the longest line, which defines the full inch. On the imperial ruler, it is marked with red, so it is super easy to read. The second longest line will be directly in the middle of each inch, which marks half an inch. The third longest line marks the quarters, so each inch is now divided into 4 equal parts. You go one step further to the fourth longest line. Now the inch is divided into 8 equal parts. Then the next step would be dividing your inch into 16 equal parts. You can go one step further into 30 seconds, 60/4, and even 1/28. Those are used in the manufacturing process for extreme precision. However, mainly we will stick to 1/8 of an inch. Quick tip: reducing fractions will make it easier to count, measure, and mark your dimensions. If your fraction can be reduced by a common denominator, it will help with reading the imperial ruler faster. So instead of saying 6/8 of an inch, which would be 1, 2, 3, 4, 5, 6, it's better to say 3/4 of an inch. Instead of saying 4/16, which is 1, 2, 3, 4, it's better to say 1/4 of an inch. Simplify the math, simplify your life. So we've gone over what scale is and its importance, and we know how to fix dimensions at various scales. We know how to read a scale ruler, or any ruler for that matter. We also know how to scale up and down. Also, we know how to read the imperial ruler. Since we have an understanding of measuring in scale, you can now apply it accurately to all your architectural drawings and models.